All right, welcome back, everybody. Today we're talking about Unit 10, which is about circles, Lesson 2, where we are measuring angles and arcs. So in circles, we want to be able to find the measures of the arcs. And today we're going to talk about central angles. We'll talk about different types of angles throughout the unit inside of circles. Today we're going to talk about the central angles. So looking at various definitions of what we're going to do, how we're going to find out what they look like. A central angle um, is where the vertex is the center of the circle, which is why we call it a central angle. It's from the center. The sides of the angle are two radii of the circle. So here, an example would be angle ABC. So it is an angle. Notice that B is the center of the circle. Anytime you see the dot there in the center, you can say that that is the center. So the arc degree, we're not going to talk about the arc degree for this one. When we start talking about minor and major arcs, so a minor arc is an arc that measures less than 180 degrees. So what an arc is, so looking at that same figure, the arc is actually the measure of going around the circle. So from arc A to C. Notice that the symbol here, we have that little curved symbol above it to note that's an arc. When we talk about the measure of an arc, we're talking about the degree measure, knowing that if a full circle is 360 degrees, that's something that we all know at this point. So AC, the minor arc, is the measure of the central angle. So this central angle is 110 degrees. So this minor arc, AC, is also 110 degrees. A major arc is an arc that measures greater than 180 degrees. Minor, smaller, major, bigger. So here we have a different one. So now we have this central angle is 60 degrees here for angle DGE. And now what we're going to do is name a major arc with 3 points, because this will give us the direction which we go. We don't want just DE, because that would represent the minor arc. Minor arc can be represented with 2 points or 3. Sometimes it has 3 if it's a minor arc. Major arc has to have 3. It cannot be represented with just 2 points. So here it's saying we're starting at D, going the direction that goes through F, so going through F to get to E. Where if we went from D to E here, we wouldn't be going through F. So going through F to E. Then what we can do is we can actually find it by doing 360 degrees minus the minor arc. So we know this minor arc is 60 degrees because it's the same as the central angle. We can do 360 minus the 60 because it's the rest of it. So this major arc would measure 300 degrees. And then a semicircle is an arc that measures exactly 180 degrees. So here we have two semicircles, both 180. Notice that we have listed with 3 points, so J through K to L, J through M to L. Both of those exactly half of a circle. Semicircle is 180 degrees. So we're going to start by finding each angle. So now we're looking at angles, knowing that a diameter forms a semicircle. So again, if you look through here, we notice that this line here is a diameter. The diameter forms that semicircle. And the various angles. So angle SCT. So SCT is this angle right here. So there are a couple different ways to do it. The way that I see it initially is we know that RCU is a diameter. So this entire thing is 180 degrees. So I can do 180 minus the 45 and 60. So I can do 180 minus 105, which is 75 degrees. SCU, so this angle right here, we just found this to be 75 degrees. So SCU combines the 75 and the 60, which is 135 degrees. Another way that you could have done it is still knowing that it's 180 degrees altogether, so 180. Then you can take away that 45, and that's 135 as well. SCQ. So SCQ is this angle here. And that one's already labeled for us. It's a right angle, so that's 90 degrees. And then our last one, QCT. So if it's an angle, when we talk about angles, the measure of an angle, we're always looking at the angle that's less than 180 degrees. Notice this isn't an arc. The arc, we said that it had to be labeled with 3, but this is an angle. So when we talk about QCT, we're talking about an angle that's less than 180 degrees. So QCT, looking at the parts, we know that this part is 90. And this part here, we said was 75. So we can add those two parts together to do 90 plus 75, which is 165 degrees. Now here we're going to be finding arcs. Okay, so finding arcs. Notice all these are arcs. We have circle O here. Angle BOA is 44 degrees. BOA is a central angle. So when it is a central angle, we know that the arc that it opens up to, so notice that this angle here opens up to arc BA. The arc measure is the same as the central angle measure. So the measure of arc BA is also 44 degrees. One of the things that hopefully we notice is that these are both diameters, so AC and BD are diameters. So since it is a diameter, it splits it into a semicircle. So this entire thing from A to C is 180 degrees. So what we can do is to find BC, we just want this part here, we can do 180 minus 44, which is 136 degrees. So this part here is 136. Okay, now what about CD? So CD is this one here. So there's a couple different ways we can do it. We can recognize that BD is, in fact, a diameter. So BD, B through C to D is a semicircle, so we can do 180 minus 136. Or we can recognize, hey, if this angle is 44, this angle here is 44 because those are vertical angles. So notice we have vertical angles. And this is still a central angle. So if that's 44, this arc here is also 44 degrees. All right, arc ACB, notice 3 letters, so start at A. So starting at A, going the direction of C all the way to B. My circles are terrible drawing on the computer, I apologize. So it's everything but the 44. So we know everything, the whole circle is 360 degrees. And we take away that part we don't want, which is the 44. So this ends up being 316 degrees. Just going to erase some of this so to get it out of the way. So once again, we said this was 44, this was 136, this was 44, this was 44. Okay, so BCD, starting at B, going through C to D. Well, if you notice, this BD is a diameter, so this is a semicircle, so this arc BCD is 180 degrees. And lastly, AD, a couple different ways you can do it. Again, you can look at this as a semicircle, so it's 180 minus the 44 just to get from A to D. You can look at it if this is 136, this is 136, vertical angles, this is 136. So if that's 136, that arc is 136. So you can either do 180 minus 44, or know if this angle here is 136, then this arc here is 136. So let's talk about arc measures. Our last concept that we're going to talk about here is arc length. So arc length is the actual length of those arcs, not just the degree measure. So there's a couple different ways you can do it. You can set up a proportion, which is the degree measure of the arc that we want to find the length of, over 360, so you're comparing the part over the whole. The arc length is the thing that we are going to find. This is our goal. This is what we want to find. That's the part of the circumference. So you have part over the whole circumference, and then you have the part of the degree over the whole. So that's one way to do it. Generally, I actually look at it as a equation where I look at the arc length as the fraction of the circumference. When we talk about the fraction of the circumference, I like looking at it like that because a general fraction will be that over 360. But you can also use other fractions. So like if you want to find the arc length of a semicircle, well then you know that a semicircle is just half the circle. So you could do half of the circumference. So that's why you normally set it up as a fraction rather than a proportion. But either one is totally okay. And so when we talk about arc length versus arc measure, the very first thing that you have to be careful of is the directions. The number one thing that people get wrong is just not being careful versus finding the measure versus finding the length. The length is the actual distance measured in units. So here the circle has a diameter of 24. Okay? So if the diameter is 24, that means that our circumference is 24 pi. Remember, circumference is pi times the diameter, so 24 times pi. So here we want to find DE if angle DOE is 120 degrees. So arc DE we know is also 120 degrees. So we can say that arc length is the fraction of the circumference. So the fraction of the circle that this is 120 over 360 times the circumference. If you want to look at it as you can simplify, so 120 over 360 is a third of the circle. So our arc length here, a third of 24 is 8 pi. I simplified it just in case, because there will be questions where you have to find it exact. You can just at this point here do 120 divided by 360 times 24 pi in your calculator. So here I have 24.1 rounded to the nearest tenth units. Again, arc length is the fraction of the circumference. So our second one is we still have that DOE is 120 degrees, but now we want to find the arc length of DEA. So piecing it together, we know this part's 120, this part's 90, then we know DEA is 120 plus 90, which is 210. So here our arc length is the fraction of the circle, so notice we're not doing the whole circle, we just want to find the length from D through E to A. It's not the whole circle, but we know that's 210 degrees out of the total possible 360 degrees. Again, times the circumference. So again, the arc length is the fraction of the circle times the circumference. 210 over 360 doesn't simplify down as quite as nice as 120 over 360. So if you want, you can just type in the whole thing in your calculator. It looks like we have round up to 44.0 units. Bring that circle down here. Alright, so just do a couple more examples. Same idea. Angle COB is 45. So the arc length of BC, this arc is the same measure as the central angle that opens up to it. So notice this angle here opens up to that arc. So we have 45 over 360, so it's the fraction of the circle times the circumference, 24 pi. All right, and we have our arc length is 9.4 units. right? And lastly, we want to find the length of arc CBA. So this is still a minor arc, but notice that it's okay. That's listed through 3 units. So started at C, went through B to A. So if this is 90 degrees, since this is a straight line, its diameter, it's 180 degrees. So if that's 90, this is 90. So together that's 45. This arc measure is 90. So CBA is 90 plus 45. So the arc measure is 135 degrees. So that means our length, the fraction of the circle, 135 over 360, times the arc, or times the circumference, 24 pi. Now we can do that in our calculator and we'll be done. We have 135 over 360 times 24 pi. We end up with 28.3 units. So again, the number one mistake in this unit is the difference between arc measure and arc length. Arc measure is the degree measure of the arc, where arc length is the actual physical distance unit. So whether it be inches or feet, or in this case just a generic unit, but it's the actual length of that part of the circumference.